A few days ago, I was looking at some photos of Mars on the internet, as you do, and I noticed these thin, straight gullies coming down the side of some of the hills and dunes. And I remember reading a long time ago that these gullies were formed from water when there used to be a lot of water on the surface of Mars. There were glaciers, and over millennia they would melt and the water would run down and form these sort of riverbeds. And that sounded plausible to me at the time. But I did some more reading and I found out that actually since 2014 that's been pretty much disproven, and NASA has a new theory. And their new theory for how these gullies formed is actually a phenomenon that doesn't happen naturally anywhere on Earth. So I thought it'd be quite interesting to talk about. But before I reveal the new theory, let's talk about some of the other options and test them out to see if they're plausible. In 1997, NASA's MGS probe first photographed these gullies, which are abundant on the surface of Mars. There are several different kinds of gullies on Mars, and for the purpose of this video we're talking about these very long, thin gullies, which can extend for kilometers. These gullies resemble riverbeds on Earth, carved out by millennia of flowing water, slowly eroding away the rock and sediment. And for several years, that was the leading theory. After all, there is strong evidence that Mars had oceans and an abundance of water at one point in its history. Until about 2 billion years ago, it had a strong enough atmosphere for liquid water to exist in large quantities on the surface. But that ancient water can't have caused all of the gullies that we see in these photos, because these gullies are far too young. But how can we possibly tell how old these gullies are? Well, just by looking at one individual gully, I don't think you could date it exactly, but NASA did notice that although there are thousands of these gullies all over the surface of Mars, not a single one of them has been obscured by a meteor crater, despite Mars having been hit by many meteors over the years. In fact, there's an area of Mars where there are multiple impact craters which are believed to have occurred about 1 million years ago, and these meteor craters have actually been covered over by these gullies, which means that the gullies must have formed less than 1 million years ago, and that's well beyond the timeline of when liquid water existed on Mars in any large quantities. So there's something else going on here. So another theory is that it's not liquid water creating these gullies, but frozen water, glaciers, which could form seasonally, break chunks off in the warmer months, and slide down the slopes creating these gullies before melting at the bottom. And that sounds a lot more plausible because Mars does still have water ice glaciers on the polar caps, which shrink in the warmer months and extend out in the colder months. Although currently these ice caps are quite small and they don't extend out anywhere near a lot of the gullies that we see, it doesn't necessarily mean that tens of thousands of years ago these caps didn't extend out further. But this theory has also fallen out of favour since NASA has been able to do spectral analysis of the gullies from some of their satellites. The spectral analysis showed no sign of any hydrated minerals, which you would expect to see if at some point in its history these rocks at the surface had come into contact with liquid water. Let's do a little demonstration with my Martian Regolith simulant, which I created in a previous video. So I've made a 30-degree inclined slope with my regolith, and this ice cube is going to represent a piece of the edge of a glacier which has broken off. It's interesting to note that on this small scale setup, the ice cube isn't at all willing to slide down the slope, even though ice cubes are known to be very low friction when they come in contact with some sort of sandy substance like this. As the outside melts, the sand sticks to it and it doesn't really want to go anywhere. I'm not saying that's representative of a large piece of glacier that's going to break off at the top of a slope on Mars, but it's interesting to contrast to a later experiment we're going to try. And while we're at it, we can use this setup to simulate the glacier melting at the top and running down as liquid water. Although we've already talked about why these gullies probably aren't formed by liquid water, it's an interesting thing to show because you can see that water sweeps away the material inside the gully and leaves the edges flat, whereas the gullies that we can see on Mars, if you look closely, seem to have raised edges on the side, which is more in line with the glacier approach, which would push the material out of the way. A third explanation, which was suggested, was that these gullies were formed by granular flow, which is essentially rocks and dust forming a sort of avalanche and falling down the slope, creating these channels. And that sounds like something that probably could happen on Mars and might well be responsible for some of the geological features we see, but the idea of it creating these thin, narrow gullies doesn't seem very likely. It's also probably worth noting at this point that although these gullies are abundant on the surface of Mars, there is a pattern to where they form. They only really form between 30 and 50 degrees latitude, which means they form nearer to the poles than to the equator, which indicates that climate could have something to do with this effect. Just for the sake of the demonstration, let's try sliding a large rock down. So we can see this rock goes down quite easily, down the 30-degree incline, and it creates that sort of gully with the sediment pushed to the edges, which creates a slight lip on each side of the gully. But of course, I'm not suggesting that there were large rocks at the top of these dunes which slid down to create the gullies and then disappeared. That would be ridiculous. But before I reveal NASA's final theory, I just want to add one more piece to the puzzle. I mentioned these gullies were young, astronomically speaking, less than 1 million years old. But even that is a vast overstatement of the age of some of these gullies, because even in the 2 short decades that we've been photographing and observing Mars, we've actually seen activity and changes in some of the gullies. And studying this activity was enough for NASA to notice a pattern. This activity always occurred in the warmer months as the polar ice caps were receding back. But when I talk about ice caps, I should specify now that Mars actually has 2 types of ice caps. It has small water ice caps, which are at the poles, and they stay solid the whole time. But on top of that, in the winter months, a large amount of the CO2 from Mars's thin atmosphere actually deposits onto the polar caps and spreads out as a thin layer of CO2 ice, or dry ice. And it's only about 1 meter to 8 meters thick, which is quite small compared to the water ice caps, but extends out much further. And this seasonal CO2 ice cap is what they think is responsible for the gullies, dry ice. Now, if you've ever used dry ice, you probably know that it has one special property that's quite different to regular ice, and the clue's in the name. It doesn't melt into a liquid, it sublimes straight from a solid into a gas, which has some quite interesting ramifications for our gully theory here. See, if we take a pellet of dry ice and place it at the top of the incline like we did with the ice cube, it actually slides down much easier than the ice cube did. And this is because as it comes into contact with the much warmer regolith, the outer surface sublimes and creates a cushion of gas which allows it to slide down with much less friction, compared to the water ice cube, which melts and sticks to the regolith and actually creates more friction. So you can imagine large chunks of this dry ice glacier breaking off in the warmer months and happily sliding down the incline for kilometers, slowly getting smaller and smaller as it turns into gas, and it'll eventually disappear as it reaches the bottom. And that, as you can imagine, will create a long, thin gully which slowly tapers away to nothing at the bottom. So that's the theory that NASA published in 2014, and I think it's pretty convincing. The gas cushioning of dry ice that we see here is an example of the Leidenfrost effect, which you can also see if you ever spilt some water on a very hot frying pan. The outer layer instantly vaporizes into the gas and actually allows the rest of the water to spin around as a little ball on the surface rather than instantly getting vaporized, which it would at a lower temperature. It's also the reason you can loosely hold some dry ice pellets for a short amount of time without suffering severe burns, even though they're minus 78 degrees Celsius at least, although it is recommended to always wear gloves when handling dry ice. But in this demonstration, as I keep it moving in my hand, it's actually much less uncomfortable than holding an ice cube, as where the water melts, it actually conducts much better into your skin, whereas the gas is insulating against the dry ice. So that's it for this video. Thanks for watching. Bye.